turbines in the grid a bad fit. Every time you turn on your microwave, make a cup of coffee, or plug in your curling iron, somewhere in the province, a generator matches the amount of electricity you're using. Plugging into the outlet in the wall isn't like plugging into a battery. It's not stored energy waiting to be used. It is actually energy that is created while you're using it. And there's a certain amount of electricity that we use all the time. It's called base load, because it's a base amount we use continually. Power generators that are not meant to start up and shut down quickly or frequently are ideal for base load generation. And nuclear power is one example of base load. Over 24 hours, energy goes up and down in a generally predictable manner. Demand is lowest when we're sleeping and highest during the middle of the day. This is an example of peak demands that the system operator expects for tomorrow. This is the older version. Water is ideal for these peak demands, or hydroelectric is ideal for peak demands as generation is simply adjusted by the amount of water flowing across the dam. And a reserve of water can be built at night and used during the day when demand is highest. However, hydroelectric stations only account for about 20% of the province's generation. Currently, the only alternative to meet these peak demands are fossil fuels such as natural gas and coal. In order to reduce carbon dioxide emissions, which is what we need to do, we need to reduce our dependency on fossil fuel generators, of course, such as natural gas and coal. They would need to be phased out or converted to carbon-neutral fuel supplies, such as biomass. What about the wind? Doesn't wind power reduce our dependency on fossil fuels? It would if you could store the power. There are not a bunch of batteries lined up inside of those tall towers. People in rural communities can put up a small wind turbine to serve their own needs and perhaps the needs of their neighbors. A battery bank can be installed in small wind turbines as a backup power supply when the wind doesn't blow. But the immense size of industrial wind turbines makes it impossible to store the power they generate. And there's no technology out there that makes it economical to store electricity of any significant amount. FIT, or the feed-in tariff, is the rate paid to corporate owners of industrial wind turbines. They receive 13 cents per kilowatt hour, but the current price of electricity is 3.5 cents. Because one cannot control the output of wind generation, not only do we still need fossil fuels to help supply peak demands, we need them even more than ever as backup for when the wind doesn't blow. Wind power in the grid, a bad fit.